Hi children, good day to all. Myself Sundara Mahalingam from Tamil Nadu. I am a mechatronics engineering. Today we are going to have a knowledge sharing session on the topic called robotics. Okay, so first of all I want to ask you how many of you watch robotic films? So there are many robotic films comes. So I will say a few more interested films are Terminator, Transformers, Endiran, The iRobot, and Big Hero. There are many robotic films which inspire the young generation toward the field of robotics. And this session will gives you the knowledge on the field of robotics and how the robots can be helpful to the humankind. So from this information you have make a decision on your future studies along your career path in the field of robotics. And so what are the topics we going to cover? So we are walk through with the following topics. What is robot? And we're going to discuss about the brief history of robotics and why we need robots and what are the classification, general classification in the robots. So what are the components of the robots, and we also have the hands-on simulation with the robot studio software tool. So actually for understanding purpose, we don't have the real robot, but we have the virtual robot with the help of software where we can give the instruction to the robot which could perform a task which we want to decide to make by the robot on a particular scenario or field. So next is what is robot. This is the first topic. So this is covers the general definition about robot. The term robot has come from the Czech word robota, which means forced or slave laborer. In 1921, Karel Čapek, a Czech playback writer, used the term robot first in his drama named Rossum's Universal Robot. According to Karel Čapek, a robot is a machine look wise similar to the human being. So you see here, this is the Honda Asimo robot, which is look like us, and this is the Rossum Universal Robot. Rossum Universal Robot drama. Here you can see the characters of the human which perform the action based on the human instruction. So actually from this slide what we can learn means, so the idea of robotics developed in start of 20th century from the Central Europe. So yeah, Karel Čapek, a person is he is a drama writer, playback writer. He write many novels, and that novels are placed in a drama. So in this drama resumes universal robots. There is a characters called Robota. Why they called us Robota means they obey his master commands. They obey the master commands. That's why their name comes as Robota. This name leads to the field of robotics in future. And then so we also see some standard definitions and provide by the specific organization like Oxford English Dictionary, and then International Organization for Standardization ISO, and then Robot Institute of America. So Oxford English Dictionary says robot, which is a machine capable of carrying out a complex series of actions automatically, especially one programmable by a computer. So here you see there is a robots are in the assembly line of car manufacturing which could perform the complex series of actions. That is, a robot can perform building, a robot can fix the roof panel, robot can fix the floor panel and joining them with the help of welding and adjusting the bolt to fix the roof over the or frame. So the complex series of action means the robot can perform a series of action, which is means if you take a action like painting a wall with the help of brush, okay, you need to move along the length of the wall. You need to move along the length of the wall. You need to change the position of your hand. So those kind of series of action can be automatically produced by the robot. Okay, that's why they define us like this. And international organization for standardization, they define in a different manner. Okay, so an automatically controlled reprogrammable multi-purpose manipulator programmable in three or more axes, which can be either in fixed in place or mobile for using industrial automation application. Automatically control means human need not to dragging the hand of the robot to perform the particular action. Okay, so it will be perform the action by own itself with the help of a controller. We will briefly discuss what are the components of the robot. The controller will perform the automatic motion performed by the robot. Okay, and it is a reprogrammable. So you should not only doing the painting over the wall. Okay, you can do various process to paint a wall. You need to first scratch a wall with the help of rough papers, and then watering the wall. Next you need to painting the wall. So the robot can do the various process. So it can be reprogrammable. So the certain wall dimension can be varied. So you can paint a small wall, you can paint a large wall. So the program itself change. So it reprogrammable machines, you can reprogram it desired depending upon your application. And this is a multi-purpose manipulator. It does not do only painting, it can do welding, it can do pick and place. If you want to pick a paint can from one place to another place, so that could also do. So it can do the multiple operation like pick and place. It can do multiple operation. And multi-purpose manipulator programmable in three or more axes. So generally the objects are represented in three dimensions, that is x, y, z. It has length, breadth, height. So the motion along the length, breadth, height plus motion along rotation along the x, rotation along y, rotation along z. So those are the various actions along the axis. It can perform the task, which can be either in fixed place or mobile for using industrial automation application. The robot can be fixed in one place to perform such a desired task which the human need, or else the robot can move in a corridor of a robot, in a corridor of industries to move the material from one place to another place. Okay, so that's why they define the robots in this manner. And according to Robot Institute of America, they define a robot in a different way. It is a reprogrammable, same. It is a reprogrammable and then multifunctional manipulator. So multifunctional manipulator designed to move materials, parts, tools, or specialized devices through variable programmed motion. So if you painting a wall means you need to change your speed of painting on the wall. So you need to variable programmed motions, so your speed can be controlled by the programmable instruction for the performance of variety of tasks. So you should not paint the wall in high speed. You need to produce the even speed to produce the even coating of the paint over the wall. Okay, so for achieving the performance to complete the task, the speed of the motion can be varied with the help of programmable instructions. So next we discuss the robotics. So robotics is a science which deals with the issue related to design, manufacturing and usage of robots, which means it is a field of study of robots. Robots are not have the same configuration. It is not look in a similar manner. It has a variety of configuration. It applied in variety of field like why aircraft. It help the human in space. It will help the human in underwaters. It help the human in military. It helps the human in medical field. it, the usage of robots are in many. There are many. So that field of study can be defined by the name robots. Wherever the robots applied in the particular field, that particular field of study will called as robotics. And the robotics term will be introduced by Isaac Asimov in a story named called Run Around. The Isaac Asimov, who is the biochemistry professor, and also he is writing many novels regarding robots, many novels regarding robots. And he is the person, he defined the laws of robotics. Based on the laws of robotics, nowadays the robots are designed and it can be used for the humankind. So we can say robotics, in robotics we use, so robotics is a multidisciplinary approach. You see in a robot you can see physics, mathematics, mechanical engineering, electronics engineering, electrical engineering, computer science, and other kind of engineering field involved in the robotics to produce the product as a robot which could perform the desired need of human task. Okay, so we can say a robot is the best example for the mechatronics. That means synergetic integration of, that is, various engineering field integrate to produce the product called robot, which could perform the task which the human needs. Okay, and what are the general laws of robotics? These laws of robotics are defined by Isaac Asimov. From these pictures you can see, okay, from these three pictures you can see the robot should protect the human being, the robot should obey the human command, the robot should protect itself. So what is the first law says? A robot may not injure a human being or through inaction. So a robot can produce the motion of action. That action should not harm the human being, but the robot can allow the human being to come to harm. So you can harm the robot, but the robot could not harm you. So this is the first law. And the second law, a robot must obey the order given it by the human being, but it should not conflict the first law. That means a human may give a command to the robot to harm another human. So it should not obey that kind of command to harm another human. So that is the second law. So that means except where such order would conflict with the higher order law. So that means the second law should not conflict the first law. And then third law, a robot must protect its own existence as long as such protection does not conflict with the higher order law. So robot should much protect itself from the external environment like rainwaters or dust and moistures, but it should obey its master command. It should allow the human to harm itself, and it should not never harm any human for protecting itself. So this is the third law. These are the three laws defined by the Isaac Asimov about the design of robotics for developing the robots. So now we get into the second topic, which is the history of robotics. So we have the brief history about robotics. So in 1920, that is start of 20th century, there is a idea generate at the Central European country which is called Czechoslovakia about robotics from the novels and dramas. The people's George Devol and the Joseph Engelberger who do the pioneering research on the robotics, and George Devol, who is the grandfather of robotics, and Joseph Engelberger, who is the father of robotics. I wrongly placed is the father of robotics as George Devol. Joseph Engelberger is the father of robotics, so Joseph Engelberger is the father of robotics, and George Devol is the grandfather of robotics. He is George Devol and he is the Joseph Engelberger. He registered his design concept of robot. He designed the design concept of robot, and he doesn't have the money resources and financial resources. He joined with a person called he's an engineer, and he's a physicist, and he's an entrepreneur. So he's joined with Joseph Engelberger to start a company called Unimation, which produced the robot called Unimate. That robot could be used in various automotive industries such as General Motors, Chrysler, and Ford Motor Company on their assembly line in the industries where the cars body is assembled and to come as a final product of cars. Okay, and then this is the robot called Unimate, which could be used in this kind of automotive industries like General Motor, Chrysler, and Ford Motor Company. And later in 1967, so after 1962, in 1967 people seeks to develop a robot to mimic the animals. So the General Electric Corporation developed a four-leg robot which mimics the horse, and this is the human developed the robot, which is the structure of the robot based on the anatomy of the animals. And this is the four-leg robot developed by General Electric Corporation. And later in 1969, and Stanford Research Institute developed a mobile robot called Seki. So, which is the first artificial intelligent robots, which leads to the path of space vehicles, the space mobile robots like rovers which is move over the moon and Mars and to perform certain analysis on the other planets. Okay, so this is the first artificial intelligence mobile robot. So the major research is the robot can move from one point to another point and make a decision by itself. If there is any obstacles along, if the robot move from this point, so this is the starting point and this is the ending point. I say the Saki to move on this path to reach the goal. This is the goal point, this is the G point goal, and this is the start point. Yes, the robot need to move from this point to this point. If any obstacle on its path, okay, I place obstacle on its path, so the robot, what it does, it will become and search there is obstacles, I need to take right and then move straight, and then I need to come left, come right, and then move straightway towards reach the goal. So this could be done with the help of a camera arrangement on this robot. So this is the first artificial intelligent robot, which is named as Saki, which is developed by Stanford Research Institute. Okay, and then next is Victor Skiman is the another robotic scientist in USA. He is a professor of Stanford Research Institute, and he joined with George DeWolf and then Joseph Engelberger, and he generated a robotic arm called Stanford arm. So which is helpful to modify the Unimate serial manipulator robot developed by the Unimation company, and that robot name called Puma, that is programmable universal machine assembly. So that could be used in General Motors automotive companies. And in 1970s, in 1970s, the Russia developed a robot called Lunacar, which is a mobile robot which is moves over the moon surface and do some analysis over the moon surface. And later the same year of 1970, Oditics, a company developed a six-leg robot which mimics the spiders. So that is called Odix 1. So it can adjust its height, adjust in width with the help of leg movement. So it has a six leg, and depending upon the environment, this height and width of the robot can be changed. So this is the development of the anatomy of the robot based on the animals and insects. And then and in 1973, and Cincinnati Richard Horn of Cincinnati, Richard Horn here. Richard Horn is the CEO of Cincinnati Millicon Corporation. He developed a robot called T3 that names as the Tomorrow Tool. This is the robot which can be used in industry for assembling the car bumper with the rear side of the vehicle, and also doing some sort of welding operation on the car frames, and also helps to load the tools on the machines such as uh, lathe machines or milling machines. It helps to load the tools over the machines. So this is the advantage of this T3 robot. And later the Rybot from Carnegie Mellon University, USA, built a one-leg hopping machine that is called one-leg robot, which is dynamically stable machine. If you place the robot on that land surface, it will be stable until the battery gets die. It will be oscillates up and down on the land region. So Rybot, from this research, Rybot begins a organization called Boston Dynamics, which is funded by USA American Defense Team DARPA, and he developed many robots which helps to army peoples in USA, like Big Dog and then the Cheetah, Petamen. He developed the many versions of the robot. Okay, that is based on this one leg hopping machines. And then the Unimation developed the Puma. In 1978, Unimation developed the Puma robot called Programmable Universal Machine for Assembly, which is used in General Motors, automotive industry sectors for the assembly line. And this Puma is developed by the Victor Schiemann, who is the professor in Stanford Research Institute, and uh, he developed the Unimate robot, and that modification takes place on the Unimate and come as a Puma robot, programmable universal machine for assembly. And this robot can be used in the General Motor automotive industries for assembly line, assembling the cars. This is the Puma robot. And the next one is Oditics. Oditics introduced the robots called Odix 1, which is the six legs robotic device. Already we see that. And the next one is the adaptive suspension vehicles, was developed at Ohio State University, USA. This is the adaptive suspension vehicle which could help the military peoples for carrying the loads, carrying the soldiers from one place to another place in the rough terrain. So this is the robot, which mimics the insect like cockroach. So while walking at a time, either one leg should be contact with the land surface, that will maintain the robot in balanced condition. And after the Saki artificial intelligence mobile robot development, the NASA, that is uh, National Aeronautic Space Administration organization, that is the space organization of the America, which sends the mobile robots such as rover to the another planet in our solar system called Mars. That is Sojourner is the mobile robot, and Pathfinder is the base station to find the path for that robot to reach the desired point on the Mars. So this is the base station called Pathfinder, and this is the Sojourner. And this mission on 1997 was a failed mission. So because the robot can survive only very few months, it's not survive for very long years. It only survive very few months only. And then next, after this failure, okay, we'll come to later. After that, in 2004, the NASA sends another Mars mission robots like Spirit and Opportunity. Before, we need to discuss the humanoid robot called Asimo, Honda Asimo. So next is in 2000, Honda developed a human-like robot called Azimo. So it height along 130 centimeters and it walk at the speed of 2.7 kilometer per hour, 9 kilometer per hour running speed, and it can be charged by lithium-ion batteries. It can work around 1 hours, and it has 57 degrees of freedom. We will see the technical terminology, what is degrees of freedom. That means these are the joints that represents the independent motion produced by the robot. So produced by the robot actuators such as motors, so that can be defined as a degrees of freedom. So we will discuss in further slides about what is degrees of freedom. So this is the first humanoid robot developed by Honda Corporation in the year of 2000. So in 2004, again the USA sent a USA starts a Mars mission with the help of Spirit and Opportunity rovers. And so the main purpose of sending this Spirit and Opportunity uh, to find any water resources on the Mars land surface. So that is the major objective of this mission. And then this Spirit can be send signal up to send signal and photographs up to 2010, and then Opportunity send signal up to 2018, send signal to the earth up to 2018. After that 2018, the Opportunity also lost signals. In 2011, a Curiosity, yeah, another Mars rover sent to the space. So to find any possibility to human can survive over the Mars for the future human mission over the Mars. So this is the Curiosity rover, which is sorry, this is the Opportunity rover. This is the Curiosity rover, which is sent on the 2011. And this arrangement, which is called as SAM, that is sample analysis mass equipment, which will collect the sand rocks on the Mars surface with the help of robotic arm. And this SAM equipment is a microwave oven which will heat the soil and rocks to perform some chemical analysis to find out the habitat for living beings in futures, for man to Mars missions in futures. So next in 2015, people developed a highly skilled artificial intelligent robots which will think like us. This is the Sophia humanoid robot developed by Hanson Robotics in 2015. So there are many kind of humanoid robot after that comes like Erika from Japan, and Geminoid from Japan, and the Honda Zimu, and then Sophia. These are the example of humanoid robots. So this is the evaluation of the robots, how the robots develop from early start of 20th century to nowadays to 21st century start. So now we're going to discuss about why we need robot. This is the third topic. And to handling boring and repetitive task. If you go to industries, you need to perform a repetitive task, but the human laborer cannot perform the repetitive task. This will reduce the product quality, that is product quality. Therefore, we require robot in industry. So robots on industry produce the industrial revolution, and the robot can perform welding car frames. So this is the car moves over the conveyor. The robot perform the welding task on the car frame to joining the metal frames of the car body. And in industry, the robot can pick and place the object from one place to another place. The robot can be pick the cardboard boxes from the conveyor and send it to the dispatch section. And the robot can be used in manufacturing. The robot can be load the object into the machine where the machining can be takes place. So this kind of operation, this kind of sequence of process can increase the productivity of the industry and reduce the production cost, because by placing the human, the salary provided to the human will be high over the entire lifetime. But if you place the robot, this will be reduce the expense of the industry and reduce the product cost and increase the quality of the product, because the humans are unskilled while doing the repetitive task. So this will increase the quality of the product. This is the gives the industrial revolution. The robots give the industrial revolution. And in certain scenario, the robot can be helpful in human to cleaning the toilets, the which the task can be discussed. The thing by the human as discussed, that task could be performed by the robot. So that task also performed by the robot. So in that essence, the robot can be replace the human in the particular field of area. And then next, the robot can be used in the dangerous environments, such as we see the robots can be sent to moon and Mars. And the robot can be helpful to the army people to disarming the bombs, disarming the mines which will dangerous, so which will dangerous to human, which will harm the human, which will make the human towards the death. So on that area, we will use the robot to disarming the bombs, which is more helpful to our soldiers in army field. And the robots can helpful help the help the army people to carrying the loads, because the while at the war field, the human carrying the soldiers carrying the more load leads to death, cannot escape from the enemy. So this will leads to the death. So this is the big talk developed by the boss Boston Dynamics, Boston Dynamics, which is the American-based, USA-based, USA-based defense equipment manufacturer, and which help the soldiers to carry the heavy loads. And the robots can help the human in the nuclear industries. So because nuclear industry filled with radiation where human cannot enter, here you see this robot perform the inspection on the water pipeline in the nuclear plant. And the robot can help the military peoples to rescuing the soldiers from the enemy lines, and also rescuing the people inside the forest fires. So they use the drones and aircraft to perform the rescue operation. This is the way the robots are helpful to human. This is the need we require the robots. And the robot can useful in medical field also. So the robot can perform surgery. So if you the robot can replace the doctor to perform the surgery, because the robot can be instructed by the doctor. He produce some hand gestures to control this arm. So the robot, that is the robot motion, the arm motion can be controlled by the doctor. And why the doctor replaced by the robot means reducing the blood loss during the surgery. That is the main need to protect the human from the death. So that is why we use the robotic surgery. And the robotic surgery uses the hepatic technology. That means the robot produces a very fine cut. This will reduce the loss of blood during the surgery. And rehabilitation during accident, human get into the disabilities. He cannot walk, he cannot move his hands. That disability can be overcome by this kind of exoskeleton arrangement. That is the external bone, that is external bony structure attached to the human body, which can the human ability to walk over the road surface, walk over the road surface and help the human could move. And the prosthetics, which is the replacement of the body parts. So this is the a person he lost his one leg during an accident. That bony part can be replaced by this bony part can be replaced by replaced by this prosthetic leg. So this is why we need robot. So robots can assist human in variety of ways. This is the general example, for proven example for why we required robots. And then we know to the come to the fourth topic, that is classification of the robot. So in this picture you see the general classification of the robot, but the robot can be classified in many ways according to mobility. Robot can classified fixed robot, mobile robot can classified into underwater robot, space robot, terrain robot, legged robot, wheeled robot. So according to its configuration, cylindrical, Cartesian robot, and articulated robot, it can be classified in many ways. According to controlled, it can be classified in various ways. But we, for our understanding purpose in this session, we will just look at the general classification of the robots. The robot and robotic devices are classified into firstly in two main categories. One is the industrial robot and non-industrial robot. So industrial robots are like human arm. This kind of robots called as articulated robot, and another set of robots called non-industrial robots. The industrial robots are used to in industry to increase the productivity, increase the quality of the product. And this is the non-industrial robot which is not used in industries, and it would be classified into assistive robot, non-assistive robot, and then assistive robot further classified into two types: non-social assistive robot, assistive social robots. And then assistive social robots can classified into two types: service robots and then companion robots. Okay, so what is assistive robots? Yeah, an assistive robot is a device that can sense, process sensory information. So what are the sensory information? It analyzes the environment with the help of camera, with the help of motion sensors, what is in and around the robot. Okay, so based on that sensor information, it perform action, it perform decision how to make the action, to move from one place to another place. Okay, to perform action. That action should benefit the people with disabilities or older adult in course of their daily living. So you see in previous slide, so this is the robotic leg and this is the exoskeleton arrangement which helps the disabled person to move in the regular routine of their life. Okay, so that kind of action performed by the robot by sensing the data in and around in their environment, which will assess the human needs. So that's why it's called assistive robots. So the assistive robot can be classified into two types. uh, Assistive robot, that is non-industrial robot, can be classified into two types: assistive robots and non-assistive robots. So non-assistive robots like humanoid robots, like we see previous slide like we see in the previous slide, Honda Zemo and Sophia, those are the humanoid robots which is think like us. They are think like us. uh, they can think like us. They can think like us. That's why it's a non-assistive robot. And non-assistive robots, and assistive robots can be classified into two types: non-social assistive robots, assistive social robots. Non-social assistive robots which does not interact with the humans. It only it motion it course of action, it perform it the actions, it motion of action could assist the human need in the real world, like make the human to move, get the mobility with the help of exoskeleton and prosthetic, which is we see in the previous slides, like this exoskeleton arrangement and the prosthetic. So that is the non-social assistive robot. That kind of robot not interact with the human. So this is the exoskeleton arrangement. It does not interact with the human but help the human need to survive in the real world, to produce the movement. And then assistive social robot. Assistive social robots are interactive robot. These robots are the system that can perceive the social entity that with the help of sensory device it can perceive the social environment and communicate with the user. It will communicate with you with the help of voices. There's interactive voices, or you can communicate with the robot by touching that display, and you can say, I want this kind of food, go and get me the food in a robotic restaurant. So this is the robot. You can touch it, display, I want this food, go and get me the chapati. So it go to the kitchen and get the chapati dishes for you and your family. So this kind of robot are called service robot. Service robot generally used in home appliance for cleaning the room, cooking in the kitchens, and serving food in the hotel restaurants, cooking food in the restaurants, helping humans in supermarket and bank sector, etc. So and it also help the elder person to in the homes. So this kind of robots are called service robot, and the companion robots are the another kind of robot which is interact with the human, and it will be interact with your child. So okay, these are the companion robot taking care of your child and monitoring your child activities. You can visualize what your child does. If your child goes to any dangerous environment, so it what your child doing when you are not in home. So this is the general classification of the robot based on its application. But there is a vast classification in the robot. For understanding session, we go with the basic classification of the robot. So what are the components of the robot? So if you see human, I have a head, I have the arm, I have the trunk, I have the hip, I have the hand, I have the foot. So similarly, the humanoid robot also has the camera eyes, metal arm, metal leg, metal body, likewise human. So it should like human. We create a robot which mimics us or which mimics the animals. So we take a industrial robot, which is the serial manipulators. So what are the components you see on the picture? I have see the controller, I have see a drive unit, I have the base platform which supports the body of the robotic arm, that is which is made up of the links. This is called links and this is called joint. This is called link and arm, this is called link and arm, this is called link or arm, this is called link or arm. And joint, that is link or arm. Okay, the joint, okay, you see the joints are connected between the two link, and it control the position of the link in the spatial region. Okay, so the controller, which is like a human brain, which gives the control signal to the joints to control the position of the link in the space. Okay, with the help of drive unit, it controls the joint motion like rotary motion or linear motion anyway. Okay, so the joints are generally made up of the actuators such as motors, DC motors, stepper motors, and servo motors, which will control the position of the link by providing the motion, that is angular motion or else a linear motion. So this is the general components in the robots. And the sensors, what are the sensors the robot has? Like human eye, it has the camera, it has the motion sensors on it, the joint, to identify the position. It has a position sensor on the joint, like to identify the angular position of the joint, how much angle the motor will be rotate, to define its position, to define the link position. Okay, so the sensor is a sensing element which could sense the environment and gives the feedback signal to the controller to control its position, that is and to control its angular position. So that is the device called sensor. Okay, so you see the in this picture you see this arm which is similar to the human arm. That's why it's called a articulated arm robot. Okay, so from this picture you can compare the human hand motion and then robotic arm motion. Okay, human hand produce the 7 way of motion, but this robot can produce the 6 way of motion. 1 2 3 4 5 6, but the human hand produce 6 way of motions. Okay, so the human shoulder joint produce the 3 motion. So the human moves move his hand front and back, up and down, and rotate the hand. Okay, and the elbow joint produce the 2 way of motion, that is folding his arm and rotating his forearm, that is fifth one. And 6 and 7 is, that is the wrist motion, up and down motion of the wrist, and then left and right motion of the up and down motion of the wrist, and then this is the seventh one, is up and down motion of the wrist, and then left and right motion of the wrist, which is 6. So this, the total human has 7 degrees of freedom, but shoulder joint produce the 3 degrees of freedom because it could produce the 3 motions, and the elbow joint produces the 2 motions, therefore it has the 2 degrees of freedom, independent motion. And the wrist can produce the 2 motion. Okay, so it has the 2 degrees of freedom. But here you see in the industrial robotic arm, that is articulate arm, each joint produces the only one motion. This is joint 1, this is joint 2, this is joint 3, and this is joint 4. Okay, this is joint 4, and this is joint 5, and this is joint 5, this is joint 3, this is joint 4, this is joint 5, and this is joint 6. Joint 1, joint 2, joint 3, joint 4, joint 5, and joint 6. So S is the joint 1, S axis, that is axis to rotate the body. It will be rotate the body around the axis. And L axis, which is the axis to move the body forward and backward. And then U axis, which is the upper arm, axis to move the arm up and down. And then R axis, which is the wrist motion, like our fifth axis. So rotate the arm around its arm length, arm axis, axis to rotate the arm. And then B, fifth axis, which is called wrist bending motion. Okay, the bending of the wrist, up and down motion. Okay, this is the fifth axis. And the sixth axis called T axis, wrist turning. So it is a rotary motion, which is the rotary motion. So each joint has the independent motion. Okay, so the number of degrees of freedom is equal to the total number of independent movement produced by this rotary actuators, such as servo motors, industrial servo motors. So the degrees of freedom generally defined as in a mechanics context, that is, a mechanics means producing the force and motion. So the mechanical system or device produce the defined mode of motion or specific mode of motion. Okay, that is, the joint can produce the rotary motion along the vertical axis, along the horizontal axis. Okay, along the horizontal axis, along the vertical axis. So it produces the defined mode of motions. So that is called degrees of freedom. Okay, degrees of freedom in a mechanics context or specific defined mode in which a mechanical device or system can move. That means in the object in a space, if you take a object if you take a object if you if you take a object, so this is my object, so this is my axis. So it can move along x, move along y, move along x, move along y, move along z, move along, rotate along x, rotate along y, rotate along z. Okay, so there are, the object in a space produce 6 way of motion. Okay, so in the defined motion, the mechanical system, if this is the motor, what is the defined mode of motion? So if you see this base joint, it can produce the vertical motion only. So defined motion, I just defined that motor can be rotate along the vertical axis. So that is the independent motion provided by this mechanical system. So that is called the degrees of freedom. So it has the one independent motion, that why it's called 1 degrees of freedom. But human shoulder has the 3 degrees of freedom. The human can activate the hand front and back, up and down, and rotate the shoulder along the horizontal axis. So the shoulder can produce the 3 degrees of freedom, and the elbow joint produce the 2 degrees of freedom, and wrist joint produce the 2 degrees of freedom. Total, the human hand produce the 7 degrees of freedom, but the articulated arm produce the 6 degrees of freedom, which is enough to achieve the particular point in this space. Okay, using this kind of motion, the robot endpoint can achieve this point. Okay, by changing the angular position of the joint, this point of the robotic arm can come to this point. Okay, and you see, this is the general components of the robotic arm. So it has the manipulator made up of series of link and joint. I have the joint 1, joint 1, joint 2, joint 3, joint 4, joint 5, joint 6. I have total 6, that is rotate the wrist, S axis, L axis, U axis, B axis, and then R axis, R axis, and then T axis. B axis is, this is the B axis, and this is the R axis. Fourth axis is the R axis, and the fifth axis is the B axis, and then sixth axis is the T axis. This is the sixth axis is the T axis. Total I have the 6 axis. And then joint provides the relative motion. By controlling the angular motion of the joint, I can reach the particular position on the space. By controlling the angular position of this joint, by controlling the angular position of the joint, I can reach this particular position in the space. Joint provides the relative motion to achieve the desired position in the space. Links, this is the link, this is the link, this is what we call as a link or the rigid member between the joint. Okay, and the link motion will be controlled by the joint angular motion. And the joints are made up of joints are generally classified into two types. One is the linear joint, and then rotary joint. Rotary joints such as motors, DC motors, stepper motors, and servo motors. Linear joints such as hydraulic actuators or pneumatic actuators, which could you see in the JCP machines, which has the linear actuator like this pipe-like arrangement. Like I have the pipe-like arrangement. So this is the linear actuators. This is the linear actuators. So this articulator robot arm has only rotary joints, and this is the this kind of body arrangement called manipulator in the robotic body. Okay, and the robot has the controller, which is similar to the human brain, which produce the complex motion of the manipulator in a comprehensive manner, elaborate manner. Okay, so to produce the complex motion in this spatial region. Okay, the controller gives the control signal to the joint to produce that kind of complex motion. Okay, that kind of complex motion can be produced with the help of programmable instruction, which will be fed into the controller with the help of programmable pendant. This is called teach pendant, where the robot interact with the human through this device called programmable pendant. From this device we can interact with the robot. So either we can use the pendant, this is the mini computer, which is called mini computer, or else through a personal computer we can interact with the robot with the help of controller. We give the instruction to the controller. From the instruction, the robot could perform the desired task, doing the picking place operation, doing building operation, and many more desired action which we want to do by the robot. So next we see the simulation of the robot. uh, for understanding how the robot obey for our instruction, we don't have the real robotic arm, but we have the virtual robotic arm that could be work inside a computer. And we will see with the help of software in the next session, next slide. Okay, students, we complete the basic understanding of robot, and for understanding purpose, we will see the example of how the serial manipulator of industrial robot works by the human instruction for the human instruction. So this is the software called Robot Studio made by ABB Corporation, who is the leading manufacturers of industrial robot. And here I create a working environment. So I will in future classes I will clearly make you clear about this software, how could you work with this software. So from our study, the robot should have a controllers and it is made up of a link and joint. Here I take the robot called IRB 1200 from the library. Here in its library I have various kind of robot model and then working environmental setup. So I can create a working environment inside this software. I can perform the simulation inside the software to understand the behavior of the robot for my instruction to perform the particular task which is I want to make by the robot to complete it. So after the robot successfully perform the task which is given by me, I use that program and implement to the real world system. Okay, so this will reduce the real world system error. So that is the purpose of creating this kind of software based simulation. And here I am going to run the simulation to make you understand how the robot work for human instruction. So the ABB robot use the programming language to program the robot called rapid program. That is make you communicate with the robot for make the robot to perform a desired task which is you want to make by the robot. So here I using that programming language called rapid programming language is similar simple instruction set which is similar to C languages. And now I played the simulation how the robot could perform the task. So you just give play button. So here also I have the pendant. I have the teach pendant. From the teach pendant itself also I can communicate with the robot. So in future classes I will say how to control the robot, how to teach the robot with the help of teach pendant. Okay. So here I created a program. Here I created a program with the help of this software. I'm not using the teach pendant to teach the robot. Here I instruct the some kind of uh, tools to teach the robot how to perform a task in this environment. I just create a target on the work table. The robot need to move over the target. So I just using the tools, using such kind of tools teach target. Using this tool I teach a target to the robot and make the robot move over my the desired target points. And I'm not teaching with the teach pendant but real world, and also in this simulation you can teach the robot with the help of teach pendant and create programming points and modify the programming point, make it link with your target. Okay, so I will play the simulation. Go to simulation tab and then play. You can see the robot will be move on your teached target points which is you want to made by the robot. Okay, here you can see from the programming also the robot will be move along, that is the cursor will be move over the instruction or instruction which is at the target which is mapped with the target points. So here move j target 10 mapped with this the 35 line instructed with the, that is 35 the line programming line 35 then mapped with the target 10 and 36 the program line mapped with the target 20, and similar way the program will be executed uh, where I mapped in the real world. Okay, so here from the teach panel also you can control the program. You can increase the speed of the robot. Okay, okay. You can increase the speed of the robot. You can increase the speed of motion of the robot. Go to, you can give 100% speed. The robot will be move at very high speed. If you want to make a robot very slow, you can give 25%. It can move very slowly, or else you can gradually reduce the speed and check how the robot can be reached the desired point. So it will be reached according the teached point on the work table based on my instruction. So thank you all. In future session we will look detailedly about the software and detail about the position analysis of this robot. There is mathematics behind the robot to reach the particular position in the space, how it can be reach the particular position in the space. Thank you all.